Okay, so this is the beginning of the torque and rotational motion chapter, and I'm going to do problems 5, 8, and 24 from chapter 8 of Giancoli. So, number 5, we have a child rolling a ball on a floor level 3.5 meters to another child, and we want to know if the ball makes 15 revolutions, what's the diameter? Okay, so this is our situation. We have a ball rolling, and we know it gets 3.5 meters, and we know that we have 15 revolutions. So we could set up our ratio. That's probably the easiest way to do it. You could do it with unit conversions too. Either way, it doesn't matter. But we know 15 revolutions for 3.5 meters is equal to 1 revolution per x meters. Okay, we do a little cross multiplication and we find x is equal to 3.5 meters per 15 revolutions. I even brought a calculator today. 3.5 divided by 15. And it should be 0.23 meters per revolution. Okay, now we want the diameter. Okay, so this right here, 0.23 meters, every time a ball rolls around, it goes the circumference. So we know this C is equal to 0.23 meters. And we also know that the formula for circumference of a circle is 2 pi r equals 0.23 meters, or since 2r is our diameter, and that's what we want, altogether pi d equals 0.23, d equals 0.23 divided by pi, which is 0.074 meters. Okay, so that's our first problem. Number 8. What we want to know is we have a rotating merry-go-round, and to make one complete revolution it takes 4 seconds. And we want to know what's the linear speed of a child seated 1.2 meters from the center, and what's her acceleration. Okay, so she's going around in a circle. It doesn't matter how big the merry-go-round is, we just care about the child, and we know that this whole time takes her 4 seconds, and we know the radius, she's 1.2 meters from the center. Okay, so if we want to know her speed, her velocity is the distance she goes divided by the time. The distance she goes in 4 seconds is the whole circumference, so that's 2 pi r, which is 1.2, divided by 4, and we get some number, 3.14 times 1.2 divided by 2. About 1.8 meters per second. 1.9, I guess, if you round. So that was one thing we wanted to know. That was part A. B, we wanted to know her acceleration. Okay, she's going around in a circle, so her acceleration is centripetal. we know AC equals V squared over R. So we have 1.9 squared divided by 1.2 is the radius, and her acceleration times 1.884 divided by 1.2 is something like 2.96 meters per second squared. Okay, so those were our geometry / unit conversion problems. I guess part B of this one required you to use centripetal acceleration. We should all be pros at that. Number 24 is a torque problem. Okay, and all it's asking you to do is find the net torque about the axle. And when it says about something, it's saying use that thing as your pivot point. So this is actually a pretty easy torque problem because all of our angles between the radius and the force are all 90-degree angles, and sine 90 is equal to 1. So, first of all, we have 3 torques, okay? We have torque 35. I'm just going to name them by how many newtons. We have torque 28 and torque 18. Okay, we use the right-hand rule to figure out which ones are positive and which ones are negative. So the 28 Newton force gives you a positive torque. The 18 Newton force has to give you a negative torque. And the 35 also gives you a negative torque. So if I'm finding the net torque, then I'm adding these things. It also says that a friction torque of 0.4 meters times newtons opposes the motion. So we need to figure out all the net of the other torque and then subtract off 0.4 newtons times meters. Okay, so we're basically just adding these things. The torque, so the sum of the torques is going to be let's do this torque first. We have 35 newtons. Okay, our angle is 90 degrees. This 135 here is just to screw you up. Ignore it, okay? And the radius, so I'm using this formula right here. I'm using F R sine theta. The radius for the 35 Newton torque is 12 centimeters, which is 0.12 meters. Okay, don't forget to convert to meters. Okay, and it's negative, so I'm going to put a negative sign there. Sine 90, I'll put it on the end, but I know it's equal to 1, so I don't care about it. Okay, now the 28 Newton torque, I'm going to add it. It's 28. The radius of the whole circle is 24, so the radius is 0.24. And then sine 90. And I'm going to subtract off 35 times 0.12 sine 90, and it's going to be plus or minus 0.4 meters newtons. Okay, I don't know whether I'm going to add or subtract this yet. I want to find out whether the total is positive or negative, because it says it works against the rest. So, 0.35. At this point, I'm just calculating. It's kind of boring, but we have 35 times 0.12, which is 4.2. So we have negative 4.2 plus 28 times 0.24, 6.72, and then minus oops, this should have been 18. And this should be 0.24. So we have 18 times 0.24, which is equal to 4.32. Okay, so the net of these guys is negative, so we know the 0.4 is acting against it. It's 0.4. So it's positive because the net of the other ones was negative. And we get some answers. 6.72 plus 0.4 minus 6.72 minus 4.2. You should get something like negative 3.8 newtons times meters. Okay, the book says meters times newtons, but same deal.